Hello and welcome to this video on section 6.4 Truth Tables for Arguments Part 2. In this video what we're going to do is learn how to use truth tables to determine the validity of arguments. So we're going to use truth tables to find out if an argument is valid or not. What I have here are the two symbolized arguments from part 1 of this video. So remember that we had the if H then S and then H therefore S argument, which was about Maria going to Harvard, and then we have our other argument over here, if G then S, not G therefore S. So remember that that was also an argument that had been symbolized or formalized. So what we're going to do now is we're going to take these arguments and we're going to build truth tables for them, and then we're going to basically determine whether the arguments are valid or not. Our first step is to determine the number of lines, and the question then is how many simple propositions are there? Well, there are two, right? So let's start with the if H then S, H therefore S argument over here on the left. There are two simple propositions because basically we have just H and S, right? We do not count the second H as another simple proposition. That's the same exact proposition. So it's only two simple propositions. So the number of lines is 4, right? We know we're going to have 4 lines because L equals 2 to the n, where n is equal to 2. So L equals to 4, right? 2 squared, which is 4. Okay, our next step is to put the premises and the conclusion over here so that we can build a truth table for them. And we separate the premises from each other with a forward slash. So we're going to have if H then S, which is our first premise, and then we're going to have H as our second premise. And so we separate it from the first premise by a forward slash. Okay, so we now separate those two premises from the conclusion, which remember the conclusion is just S, by a double forward slash. So here we have the whole argument, except it's shown or expressed differently. We have if H then S, H therefore S. We have the one forward slash separating the premises from each other, and then we have the double forward slash separating the conclusion from the premises. So we have set it up now so that we can start to put in the truth values. Right now we can put in the truth values. Okay, well remember the truth value distribution starts with taking all the truth values and splitting them in half. And in this case, you know, it's going to be 4 lines, so we're going to have TTFF on the first column, right? The reason for that is because if we take, since we know it's 4 lines and we take all the truth values and split them in half, we know we're going to have 2 T's and 2 F's. So on the first column over here, we're going to have TTFF, and I also have the second column up here already. And so remember, the second column we get by taking the TT and splitting it in half, and that would be TF, right? And so we take the TT and split it in half, so that would be the TF. We do the same thing with the FF, right? We split it in half, and that's the TF. Notice that under the S we have the alternating scenario. We have TF, TF, right? And so remember our initial distribution, which is, that's what this is right here. We have our initial distribution is such that we would have that last one as alternating, as TF, TF. Okay, now what we do is we basically copy and paste the truth value distributions under the columns onto the other H and the other S, because that would have the same exact truth values in terms of the simple propositions. So under the H we would have TT, and then FF, right? And then under the S, since that's alternating, we would have TF, TF, right? So let's put those truth values under the S, which remember, that's in this case, that's our conclusion. So that would be TF, TF. Okay, that's it. We have the initial distributions. Now the question is, do we need to compute anything? Okay, well we do. We need to compute this antecedent. I'm sorry, this conditional. and that's because it is the only one that has a truth function attached to it, right? It has the conditional. It's called the operator. It's the only one that has an operator. Notice that the second premise, the H, doesn't have anything that needs to be computed. And then the conclusion, the S, doesn't have anything that needs to be computed. So our next step here is to compute that premise. And because it's a conditional, it's going to be, we're going to use the conditional. So if true, then true is true, right? And let's make this in blue. If true, then false is false, right? So the second row here is false. If false, then true is true. And so our third row is true for that first premise. And then if false, then false is true, right? So our fourth row, our fourth line is true. Okay, now this is our final computation. The letters in blue here are our final computation for the first premise. And there isn't anything else that needs to be computed. Okay, now we do basically our final step here, which is to determine validity. Remember, that's what we were doing here. And so the key here is to ask ourselves, is there a line such that the premises are true, but the conclusion is false? And if there is such a line, such that the premises are true and the conclusion is false, then the argument turns out to be invalid. Why is that? Well, remember that the definition of validity is that if the premises are true, the conclusion has to be true. And so if there's a violation of that definition, that is to say if there's a line in which the premises are true but the conclusion is false, then the argument is automatically going to be invalid. So let me put numbers next to the lines because we will need the numbers here for a little bit. I'll show you why. Okay, so if we look at the lines, there is no line where the premises are true and the conclusion is false. We don't find such a line. In all of them, we do have, we just don't have that scenario. Let's look at the first line. And I've colored everything in blue that we're looking at in order for us to ask ourselves that question. Is there a line such that if the premises are true, the conclusion has to be true? And so the reason that I did it in blue is so that it's clear what we're looking at. Okay, there is no such line. In the first line, we have TTT. We have the first premise is true. The second premise, which remember is under that H, as true as well, and then the conclusion is true. So that's not a line where we have TTF. Second line, we have FTF. Okay, well there's no TTF there, right? There's no. It's not the case that the premises are true and the conclusion is false, so we're okay there. And then the third line, we have TFT. Again, we don't have TTF, right? We don't have a case in which the premises are true and the conclusion is false, so we're fine there. And then our last line, we have TFT, right? Well, again, we don't have a case in which the premises are true and the conclusion is false. So this argument is valid. Because we don't have a case in which we would have TTFF, the argument is valid, and so we would just write valid as our answer here, okay? So that's it for that argument. Let's go on to the next argument. So valid, I'm writing valid at the bottom here because that's what we were after. Remember, we were trying to determine whether it's valid or not. So when you do your homework, you do need to write valid or invalid. And so that's what that is your final answer. But of course, you will also need to show the truth table for your homework. Okay, so that's it. That argument is valid. I've shown you why. Let us go to the next argument here, the second and last argument. Okay, well, in the next argument, we have again we have premises and we have a conclusion. So we're doing the same exact thing. We're taking the premises and we're separating them from the conclusion. And so this is the same exact procedure. So our first premise is if G then S, right? So remember, we write it over on the left. We separate it from the next premise, which is the not G, by a forward slash. So our second premise is the not G, that's the tilde G. And our conclusion here is the not S, and remember we separate that from the premises with a double forward slash. So the not S comes last. That's because that's our conclusion. And so that will be all expressed this way. Okay. First premise, if G then S. Second premise, not G. And conclusion, not S. Separated by the slashes there. One slash for separating the premises. Two slashes for separating the premises from the conclusion. Okay, so next we just assign the initial truth values. So again, remember we are taking these values and we're putting them there. How many simple propositions do we have? We have two simple propositions. We have G and S. Remember that the not G and the not S do not count as a third or fourth proposition. We only have G and S. And so the number of lines is 4. L equals 2 to the n, where n is 2. So L equals 4, right? So that's our initial truth value distribution. Let me make a little bit of space here in between these. Okay, so it's the same thing. I just made some space here. Okay, so if we copy and paste the truth values for the G, we would have T, right? I'm just copying and pasting the truth values, and then F, right? So that would be our truth values for the second G here, right? We're not worried about the tilde yet. We'll get to the tilde in a second. And then the S, right? The S is the TF, right? That's our alternating one. So that will look like this, TF. And then TF. Okay, this is our initial truth value distribution. This is our truth value distribution. Now we ask ourselves, okay, is there anything that needs to be, are there any computations that we need to make? Are there any truth value computations that we need to make? The answer is yes. And in fact, in this case, we're going to have to do computations for all premises. Notice that I'm doing the computations separately for each premise, that the computations here are kind of independent, right? We're not computing the whole argument at once. And notice that I did that in the last argument. I did it separately, right? And so we're doing that here as well. So the first premise is if G then S, and so we do the computation for that one. Well, that's the conditional. So if true, then true is true. If true, then false is false. If false, then true is true. And then if false, then false is true as well, right? That is our conditional, which is our first premise here. Let's go ahead and do the computation for the next premise. Let me make the this in blue, so that we'll leave everything in blue that needs to be looked at the end to determine if the argument is valid or not. So let me make that in blue. Okay, so we go on to the second premise, and remember we compute the second premise independently. That is to say, we don't really care about the other premise and we don't really care about the conclusion. We just compute it independently. We have independent computation here for each premise and the conclusion. Okay, well the second premise is a negation, right? It's not G. So we have the truth values for G, so we basically just have to worry about the negation, which remember is always the opposite. So that's going to be F. That's going to be F. This is going to be T, right? And then the other one here will also be T. Okay, let me move that over a little bit to the right. And then let me also make the final result here in blue, which remember is the what's supposed to be under the tilde, right? Okay, so that means that the F here should be in blue. The F there should be in blue. And the T there should be in blue. And the T there should be in blue. Okay, so that's our final computation for the second premise. And now we finally move on to the conclusion, right? Well, the conclusion is also a negation. It's the negation of S. Well, that means that we just do the opposite truth value, right? So for the first one, it would be F. The second one would be T. The third one would be F. And the fourth line here would be T, right? Okay, that is our values under the conclusion. But remember, what we care is what's under the tilde here. And so let's make that in blue, because that's basically our final truth value result for the conclusion, right? So let's make them in blue. Okay, so we now have what we need in order to ask ourselves the question, is the argument valid? Okay, well, again, remember, what we have to ask ourselves is there a line? Oh, and let me number the lines. Don't forget that in this case, the lines do have numbers, and you'll find out why in a second. So we had not done this before, where the lines would have numbers. So, okay, why they have numbers, we'll get to that in a second. Let me move everything over a bit so that it's all straight. Okay, let's go and find out whether it's valid. Okay, so remember, the question is there a line such that the premises are true but the conclusion is false? And the reason that we're doing that is because if there is such a line where the premises are true and the conclusion is false, we have a violation of validity, right? Because remember, the definition of validity is that if the premises are true, the conclusion has to be true. So if we have a scenario where the premises are true but the conclusion is false, we would automatically have an invalid argument. Okay, so is there such a line? Okay, well, let's see. Everything is in blue, so what we're looking at is in blue. In the first line, we have TFF. There's no problem there, no violation of validity. Second line, we have FFT, no problem there, right? No violation of validity. Third line, TTF. Oh, look at that. There's a violation of validity, right? Because the premises are true and the conclusion is false. This means that the argument is invalid automatically. We could look at the fourth line, TTT. Okay, no problem there, but because we have that one line in which the premises are true, and that's the third line, and the conclusion is false, the argument is automatically invalid. So our answer here will be invalid fails in line 3. And this is the reason why we needed to number the lines, because we need to indicate exactly where the argument fails to be valid. So our answer here is invalid fails in line 3, and this basically tells us that the argument is invalid because we have a case there where the premises are true and the conclusion is false. Okay, that is it for this video. In your homework assignment, you will be doing the truth tables, and you will be using them to determine validity, just like we did in this example here. Okay.